Welcome to Chapter 1 of Class 9 Science, Matter in Our Surroundings. In this fascinating chapter, we'll explore everything around us that occupies space and has mass, what we call matter. We'll investigate what matter is made of, how it behaves in different states, and how it changes from one state to another. From the air we breathe to the ground we walk on, from the water we drink to the stars in the sky, it's all matter. Get ready for an exciting journey into the world of particles, states of matter, and the amazing phenomena that occur all around us every day. Let's begin with the fundamental question: what is matter made of? For centuries, scientists debated whether matter is continuous like a block of wood or made of tiny particles like sand. Through experiments like dissolving salt in water, we now know that matter is made up of extremely small particles. When we dissolve salt in water, the water level doesn't rise significantly because salt particles fit into the spaces between water particles. Even more amazing, just a few crystals of potassium permanganate can color about 1,000 liters of water. This shows that particles of matter are incredibly small, much smaller than we can imagine. These tiny particles are the building blocks of everything we see around us. Now let's explore the characteristics of these particles. Particles of matter have three important properties. First, they have spaces between them. That's why salt can dissolve in water and smells can spread through air. Second, particles are always moving. This is why ink spreads in water and why smells reach us from a distance. Third, particles attract each other. This is why solids hold their shape and why it's hard to break some materials. The movement of particles increases with temperature. That's why diffusion happens faster in hot water than in cold water. These three characteristics, spaces between particles, continuous movement, and attraction between particles, explain many everyday phenomena. Let's explore the third characteristic in more detail, the attraction between particles. We can understand this through a human chain activity. When people hold each other tightly like traditional dancers, it's hard to break the chain. This represents strong attraction between particles in solids. When they just hold hands, the chain is easier to break, representing medium attraction in liquids. And when they barely touch fingertips, the chain breaks easily, representing weak attraction in gases. Different materials have different strengths of attraction between their particles. Iron has strong attraction, making it hard to break. Chalk has weaker attraction, making it break easily. Rubber has attraction that allows stretching. Understanding particle attraction helps us understand why different materials have different properties. Now let's explore the three states of matter that we encounter every day. Solids have definite shape and volume, like your pen, book, or a wooden stick. They're rigid and maintain their shape under force. Liquids have definite volume but no fixed shape, like water, oil, or milk. They take the shape of their container and can flow. Gases have neither definite shape nor definite volume, like the air around us. They fill any container completely and are highly compressible. These different states arise because of differences in how strongly particles are attracted to each other and how much they can move. In solids, particles are closely packed with strong attraction. In liquids, particles are less ordered with medium attraction. In gases, particles are far apart with weak attraction. Let's focus on the gaseous state, which has some fascinating properties. Gases are highly compressible. That's why we can fill many balloons from one gas cylinder. When we compare syringes filled with air, water, and chalk, only the air-filled syringe compresses easily. This compressibility makes gases very useful in daily life. LPG for cooking, CNG for vehicles, and medical oxygen are all stored as compressed gases. Gases also diffuse very rapidly, that's why we can smell perfume from across a room. The large spaces between gas particles allow them to be compressed and also enable rapid diffusion. Understanding gas properties helps us appreciate technologies like gas cylinders and explains natural phenomena like wind and air movement. Now let's explore how matter changes from one state to another. Water can exist as ice, solid, water, liquid, and steam, gas. What causes these changes? The key factors are temperature and pressure. When we heat ice, it melts at 0 degrees Celsius to become water. When we heat water, it boils at 100 degrees Celsius to become steam. During these state changes, the temperature remains constant because the heat energy is used to overcome the attraction between particles rather than increase their kinetic energy. This hidden heat is called latent heat. The reverse processes, condensation and freezing, release this latent heat. Understanding state changes helps us explain everyday phenomena like why ice cools drinks and why steam causes severe burns. Some substances can change directly from solid to gas without becoming liquid. This is called sublimation. Ammonium chloride, camphor, and iodine show this behavior. When heated, they form vapors directly. Dry ice, solid carbon dioxide, also sublimes at room temperature, which is why it's used for special effects in theaters and for cooling. Pressure also affects state changes. When we apply pressure to gases, we can liquefy them. This is how LPG and CNG are stored in cylinders. Reducing pressure on liquid carbon dioxide produces dry ice. These phenomena show how temperature and pressure can dramatically change how matter behaves, enabling many practical applications in daily life and industry. Now let's explore evaporation, the process where liquid changes to vapor at any temperature below its boiling point. We see evaporation in wet clothes drying, water disappearing from ponds, and sweat cooling our body. Evaporation is affected by 4 main factors. Surface area, larger area means faster evaporation. Temperature, higher temperature means faster evaporation. Humidity, lower humidity means faster evaporation. And wind speed, higher wind speed means faster evaporation. Evaporation causes cooling because the particles with highest kinetic energy escape first, leaving the remaining liquid with lower average kinetic energy and therefore lower temperature. This cooling effect has many practical applications. Finally, let's compare evaporation and boiling. Both involve liquid changing to vapor, but they're different processes. Evaporation occurs at all temperatures, only at the surface, is a slow process, causes cooling, and doesn't form bubbles. Boiling occurs at a fixed temperature, throughout the liquid, is a fast process, doesn't cause cooling, and forms bubbles throughout the liquid. Understanding these differences helps us use these processes effectively. Evaporation is used in drying clothes, cooling water in earthen pots, and regulating body temperature. Boiling is used in cooking, sterilizing water, and industrial processes. Traditional knowledge, like using earthen pots for cooling water, shows how people have used evaporation principles for centuries. This chapter helps us understand the fundamental nature of matter and its behavior in our daily lives.